Hi everyone, welcome back to our statistics class notes. Okay, we're on the last page of section 9.3 and I want to go ahead and finish up the example we started on the previous page. Actually, we started on page 146. So remember that we have data on the speed in miles per hour for a random sample of 30 cars traveling on a highway that was collected. The mean speed, so the sample mean, the x bar, 63.3. With the standard deviation, so S, a sample standard deviation S of 5.23 miles per hour. We checked the conditions for the central limit theorem for means to make sure it was satisfied, and I showed you how to construct this confidence interval using StatCrunch. We came up with the 95% confidence interval of 61.35 to 65.25. And I also showed you how, if you really wanted to, we could find that T star, the multiplier within the margin of error. Remember, the margin of error is T star times the standard error estimate, which is S over square root of N. So T star, it's not like Z star, which we were able to memorize a few of them for computing a confidence interval for a population proportion. T star is different for every sample size, so we just let StatCrunch do it. But if you actually needed to know what it is, I've shown you here how to do it. So interpreting that confidence interval we just found, we would say that we are 95% confident that the mean speed of all cars traveling on this highway is somewhere between 61.35 and 65.25 miles per hour. And the question that we might pose is it plausible that the mean speed of cars on the highway is 67 miles per hour? Why or why not? And when we look at the confidence interval, we see that it runs from 61.35 to 65.25. So 65 is outside of that confidence interval. Thus, it is not a plausible value for the mean speed of the cars on the highway. And one last example. Let's do an example on movies. Let's say we take a random sample of 35 college students, so that's our sample size N. And they were asked how many movies they had seen in the previous month. The sample mean, so the average for this sample, which is X bar, was 4.14 movies, and the standard deviation was 10.02 movies. That's sample standard deviation of S. So let's construct a 90% confidence interval first, and then if we were to use the data to construct a 95% confidence interval, would that interval be wider or narrower? Let's go ahead and answer that right away. Remember, as the level of confidence increases, the width of the confidence interval also increases. So the 95% confidence interval would necessarily be wider. Now, what would be the effect of taking a larger sample on the width of the interval? So now, if we kept it at 90% and we took a larger sample, then that means our margin of error would be smaller, right? Because the standard error would be smaller, which is S divided by square root of N. And the larger N makes a smaller standard error, which makes a smaller margin of error. So that would give you a narrower, less wide 90% confidence interval than the 90% confidence interval with 35 sample mean gave us. 35 sample size gave us. Okay, again, remembering how we compute this confidence interval for a population mean, we have to put in the sample mean X bar, 4.14, put in the sample standard deviation, 10.02, put in the sample size, 35, and make sure we select 90 on the 90% confidence interval. And hit compute, and here's our results. So the 90% confidence interval is 1.2761 to 7.0039. That means we are 90% confident that the true population mean, true average of college students, the number of movies they see is somewhere between 1.28 and 7.0 movies per month. Again, I've explained these already. The 95% confidence interval will be wider than the 90%. Because the 95% confidence interval would have a larger margin of error because of its larger T-star multiplier. Okay. If we took a larger sample, the standard error would be smaller, right? Because the standard error estimate is S divided by the square root of N. So this means the margin of error would be smaller, thus the interval would be narrower.